Close your eyes for a moment and imagine drifting in the silence between galaxies. At first, it feels empty, an endless ocean of blackness with only a few scattered stars. But if you could float farther past the haze of the Milky Way, past the clusters of light that dot the heavens, you would see something astonishing. You would notice that galaxies are not scattered randomly like sand thrown in the air. They are connected, bound, strung together by a hidden thread that no telescope can see directly, but whose presence is written across the entire sky. Astronomers call it the cosmic web, a vast, invisible structure made of filaments, clusters, and voids stretching farther than the human mind can comfortably imagine. It is the scaffolding of the universe, the secret framework on which every galaxy, every star, every planet, even us, has been built. And yet, we live our lives unaware, as if standing inside a cathedral and never looking up to see the roof. Tonight, we will wander into this silent architecture, tracing the invisible paths that hold creation together, a silent fabric, stretching across the cosmos. When scientists first mapped the sky in detail, they expected chaos. Galaxies scattered in every direction, like dots on a blank canvas. But instead, something remarkable appeared. Great rivers and walls of galaxies stretching across billions of light years. It was as if the universe was stitched together by threads too large to comprehend. Picture yourself standing on a mountaintop at night, gazing at stars and realizing the darkness between them is not empty at all. The silence of space hides this fabric, but its presence is undeniable. Gravity whispers across these threads, pulling galaxies into line, shaping them like beads sliding down a string. This is not a surface you can touch, yet it is strong enough to sculpt the largest objects known. Think of it like a spider's web, invisible in the dark until the morning dew reveals its perfect design. That is what astronomers began to see when the universe was mapped in 3 dimensions. The wonder here is that something so vast remains unseen by our eyes. We look at stars, but the stars only reveal a tiny fraction of the stage. Behind them lies the scaffolding that decides where everything can exist. And the more we uncover, the more the cosmos feels less like emptiness and more like an immense living pattern. What does it mean then to live inside a universe built on a hidden fabric? It suggests that connection, not isolation, is the law of existence. Even in the loneliest corners of deep space, galaxies are not drifting aimlessly. They are joined, held, and guided by this quiet geometry. Like travelers on invisible highways, they move together in ways we are only beginning to understand. And if galaxies themselves are not solitary, can we ever truly think of ourselves as alone? This invisible web hints at something deeply poetic, that every part of creation, no matter how far, is joined by threads that never break. The first glimpse of patterns beyond stars. The realization didn't come all at once. Early astronomers saw only fragments, scattered dots on paper, the faint suggestion of clusters. But with each new survey, with each telescope aimed deeper into the night, the picture grew clearer. Imagine being one of those scientists expecting randomness and instead watching a cosmic pattern unfold before your eyes. The sky was not. It was a map, a secret arrangement written into the very bones of the universe. At first, these patterns seemed unbelievable. How could galaxies, separated by millions of light years, arrange themselves into long filaments? But evidence piled higher. Photographic plates became digital data, and computers revealed structures far too vast for imagination alone. Suddenly, astronomers were sketching not isolated islands of light, but sprawling chains of galaxies stretching farther than anything ever known. These were not illusions, they were confirmed by independent eyes, different instruments, and repeated measures. A hidden order revealed itself, one that had always been there, waiting for us to notice. It was as if the cosmos had been whispering a secret for billions of years, and humanity finally learned to listen. That first glimpse changed everything. For the first time, we began to understand that the universe does not expand as a simple fog of matter, but as a structured web. Some regions grew crowded, filled with galaxies pulling together into clusters. Others were left hollow, vast voids where very little resides. The balance between these regions created a tapestry, dark and light, crowded and empty, spread across all of existence. And in that moment of realization, a deeper question arose. If the stars are arranged in patterns far larger than we imagined, then perhaps the universe itself is not a random accident, but something that has been shaping itself with quiet intention all along. Galaxies refusing to stand alone. Take a single galaxy, the Milky Way for example. It looks like an island of light floating solitary in space. But look closer and you'll see it is not alone. Dozens of smaller galaxies orbit it like companions. Beyond that, it belongs to a cluster, a group of galaxies bound together. And even beyond that, it is just one node in a filament stretching into the deep. It's humbling, isn't it? We often imagine galaxies as solitary wanderers, but none truly live alone. They are gravitationally linked, dancing in relationship with others, moving in slow but inevitable flows. Think of them as notes in a symphony. No single note carries the song, yet each one matters to the music of the whole. The refusal of galaxies to stand alone tells us something profound, that cooperation, not separation, is written into the cosmos. When two galaxies meet, they often merge, creating something new. Their stars mix, their dust combines, their black holes spiral together until one remains. Out of collision comes creation, and out of connection comes growth. It is a pattern repeated everywhere we look. What we see on the grandest scales echoes in our own lives. Just as galaxies need one another to evolve, so do we. Isolation may feel real, but the universe suggests otherwise. Every being, every star, every atom is tied into a larger fabric. And perhaps that is why the web feels less like science and more like a story that includes us all. This truth changes how we think of existence itself. A galaxy cannot escape its place in the cosmic web, just as we cannot escape our part in the greater whole of life. The invisible threads tug at us too, unseen forces of connection, family, community, and memory that shape who we are. We may not always see them, but they are there. And so every time we gaze at the Milky Way above, it is worth remembering. We are looking at a single bead on a thread of countless others, all strung together in silence, stretching beyond what we can ever travel. The mysterious bridges of cosmic matter. Between galaxies lie bridges, not bridges of stone or steel, but of gas, dust, and something even stranger, dark matter. These bridges connect galaxies across the abyss, channels through which gravity and energy pass. Imagine rivers running through a desert, unseen in the sand, but vital to the life that gathers there. The cosmic web works much the same way. For billions of years, these bridges have guided the growth of the universe. Galaxies form where the bridges are strongest, like trees rooted along a hidden riverbank. Stars ignite, planets form, and eventually life begins, all because of the silent architecture of these threads. Without them, matter would be scattered thinly across infinity, never gathering into the structures we call home. What's fascinating is that these bridges are made largely of something invisible, dark matter. Though we cannot see it, we can trace its fingerprints, its gravitational pull, bending light and guiding galaxies. It is the ghostly backbone of the universe, the unseen architect whose presence is felt in every cluster and filament. Without it, there would be no bridges, and without bridges, no galaxies at all. These bridges also remind us of the mystery we are still wrapped in. Every discovery reveals more questions. What is dark matter? Why does it exist in such abundance? And why does it form these structures instead of dissolving into chaos? Each bridge across the universe is both an answer and a riddle, inviting us to wonder what lies beneath the visible surface of reality. As you drift in thought tonight, imagine traveling along one of these cosmic bridges, a silent highway of invisible matter stretching between galaxies. Perhaps you would feel the faint tug of gravity guiding your path, like an unseen hand leading you forward. These bridges may be invisible, but they are the veins through which the lifeblood of the universe flows. Threads that hold light itself together. It may sound impossible, but even light is caught in this cosmic web. When it travels from the edge of the universe to reach our eyes, it bends and twists along the filaments of matter. This bending, called gravitational lensing, acts like a natural telescope, magnifying galaxies that would otherwise remain hidden. In other words, the web doesn't just hold galaxies, it even shapes the path of light itself. Imagine a distant galaxy, billions of light years away. Its light begins a journey long before Earth even existed. As it travels, it weaves its way along the invisible scaffolding of the cosmic web, pulled and redirected by the mass of unseen matter. By the time it reaches us, that light has carried not just an image, but the fingerprint of the web that guided it. Every star we see is filtered through this silent architecture. This is perhaps the most humbling truth. The universe is not just shaped by the web, it is revealed through it. Without the bending of light, we would never know the web exists. It is as if the cosmos left behind a subtle signature, a way for us to trace its hidden form. Light itself became the messenger, carrying secrets across time and space. Think about that for a moment. Every time you look up at the night sky, the light that touches your eyes has traveled through an invisible net stretched across billions of years. What you see is not only stars, but the pathways of the universe itself, painted softly across the canvas of night. It is both a scientific fact and a poetic gift. And so the web does more than hold galaxies together. It holds stories, memories, and the very history of the universe itself. Without it, light would not find its way to us in the same way, and the night sky would not carry the depth of meaning that it does. We are not just observers of the web, we are illuminated by it every night of our lives, a universe, not empty, but woven. For centuries, the common belief was that space was simply nothing, a vast emptiness sprinkled with stars, but the more we peered into the deep, the more that story unraveled. What looked like a void was, in fact, filled with invisible connections. The cosmic web transformed our understanding. The universe isn't a blank page with dots of ink, but a woven fabric where threads dictate the positions of galaxies themselves. This idea reshaped astronomy. Suddenly we weren't just charting isolated lights, we were tracing the hidden roads between them. Imagine walking into a forest at night thinking trees stand alone, only to discover roots beneath the soil connect them all. That's what the cosmic web revealed. Galaxies as blossoms on an underground network far greater than we imagined. The fabric of the cosmos, while unseen, is not abstract. It is tangible in its effects. It guides gravity, directs matter, and defines where galaxies can form. In truth, it is the skeleton of the universe, and everything we know is built upon its frame. The night sky, in all its beauty, is only the decoration draped across that invisible scaffolding. What makes this realization profound is not just its scale, but its intimacy. If the web exists everywhere, then it also surrounds us, our own Milky Way embedded like a pearl in the weave. We are not floating in emptiness, we are nestled within a structure that stretches across all creation. The universe is not empty at all. And when you think of it that way, the night sky changes. Instead of random sparks in a void, you begin to sense a unity, a quiet design. The stars stop feeling scattered, they start feeling connected, as if each one belongs exactly where it is meant to be. The gravity that tugs like an invisible hand, at the heart of this web lies a force so familiar yet so mysterious, gravity. We know it as the pull that keeps us grounded, the weight that binds us to Earth. But in the vastness of the cosmos, gravity becomes the invisible hand weaving galaxies into place. It stretches across billions of light years, drawing matter into threads and knots, sculpting the cosmic web without ever being seen directly. This gravity is patient, unimaginably so. Over billions of years it tugs softly, gathering dust, stars and galaxies into great structures. No rush, no forceful snap, just an eternal whisper that shapes creation itself. Like a sculptor who chisels stone grain by grain, gravity has carved the universe into its present form. And we are living in its artwork. What's curious is how gravity interacts with other cosmic forces. Dark energy pushes the universe outward, stretching space itself, while gravity pulls matter inward, weaving threads of the web. The balance between these two has determined everything. Where galaxies form, how they cluster, even how long stars like our sun can shine. It is a delicate tug-of-war written into the bones of existence. And yet, for all its strength, gravity is subtle. You cannot see it, only its results. Light bends, galaxies cluster, paths curve where they should not. Each of these is gravity's fingerprint, evidence of its patient hand arranging the cosmos. To gaze into the night is to see its invisible signature across the heavens. If you listen closely, you can almost imagine it as a song, a deep, endless note humming quietly in the background of time. A soundless melody that has been playing since the universe began, guiding galaxies to their rightful place. Dark matter's hidden sculpting power, but gravity alone cannot explain the web. There is something more, something unseen, dark matter. It neither shines nor reflects light, yet it outweighs all visible matter by far. Without it, the threads of the web would not exist. It is the hidden scaffolding upon which galaxies are built, the silent sculptor that draws the lines of creation. We only know it through its pull. It bends light from distant galaxies, revealing itself through gravitational lensing. Like an invisible artist, it leaves traces we can measure, though the canvas remains unseen. Without dark matter, galaxies would scatter apart. Stars would drift like lonely sparks. The universe as we know it would never have taken shape. Imagine looking at a building and realizing the beams are hidden behind the walls. The beauty of the structure is visible, but the true strength lies where the eye cannot see. That is what dark matter is to the cosmos. It is the frame upon which everything else hangs, silently holding up the weight of the universe, and still, its nature remains a riddle. What is it made of? Why can't we touch it or see it? Some believe it is a new kind of particle, one we have never detected. Others wonder if our understanding of gravity itself needs rewriting. The mystery endures, urging us deeper into questions that may take lifetimes to answer. Yet whether explained or not, its effect is certain. The cosmic web is its masterpiece, Every filament, every cluster, every bridge of galaxies, all carved by the invisible hand of dark matter, shaping the stars we see and the planets we call home. Streams of galaxies flowing like rivers. If you could drift above the universe and look down upon it, you would see something breathtaking. Galaxies streaming along filaments like rivers of light. They flow gently, drawn by gravity, into channels carved by dark matter. These are not random paths, but organized streams, each guiding galaxies toward massive clusters, cosmic cities where thousands gather together. It is almost as if the universe is alive, its galaxies moving in slow, deliberate migration. Imagine watching clouds gather into storms or rivers winding through valleys. The streams of galaxies follow similar laws, shaping their destinies over billions of years. They are travelers, each pulled along currents invisible to human eyes. This flow explains why galaxies are not scattered like dust. They are channeled into patterns like beads on a necklace, each one carried by the river of gravity. And within those streams, galaxies collide, merge, and transform, just as water carves new paths through stone. The universe is not static, it is endlessly moving, evolving along these currents of creation. For us on Earth, this motion is imperceptible. A galaxy may take billions of years to drift along its filament, but when scientists map them out, the picture emerges: immense highways of galaxies, rivers of light flowing across the dark. To glimpse such a pattern is to realize we are inside something vast and flowing, a current of time and space itself. And if galaxies flow like rivers, then where do they lead? The answer lies in the clusters, immense knots of gravity drawing in streams from every direction. These are the hubs of the cosmic web, the gathering places of galaxies on their endless journey, the shape of a web no eye can see. Now imagine stepping back even farther, not just a river here, a cluster there, but the entire web at once. What you would see is extraordinary, a pattern resembling a spider's web or the neural pathways of a brain. Filaments stretching, knots forming, voids expanding. A cosmic design that feels strangely familiar, almost as if nature repeats itself across every scale. No eye can see this web directly. It exists in maps, simulations, and mathematical models built from decades of observation. But the image it paints is haunting. The largest structures in the universe mirror the smallest structures inside our own minds. The cosmos and consciousness seem to echo one another, bound by the same invisible geometry. This shape is not random. It formed from tiny fluctuations in the early universe, amplified by gravity and sculpted by dark matter. Over billions of years, those tiny ripples became the vast filaments we now trace across space. What began as whispers grew into the greatest architecture ever built, the web that holds everything together. To see this pattern is to feel both small and deeply connected. Our galaxy is just one point in this network, yet that point is part of a structure so immense it defies comprehension, and still we belong to it. Our place in the web is not separate, it is essential, one thread in a design that spans eternity. And so the cosmic web is not just science, it is a story of order born from chaos, of hidden hands shaping the stars, of patterns repeating across nature. And as we open more of this story, we step into the vast walls, the hollow voids, and the secrets written in the architecture of the universe itself. When clusters gather in cosmic cities. If you picture galaxies as homes, then clusters are cities, vast gatherings of hundreds, even thousands of galaxies bound tightly by gravity. They are not scattered neighbors, but bustling metropolises of stars, gas, and dark matter. In these cities, galaxies interact constantly, pulling on each other, merging, and shaping one another's destinies. They are the crowded downtowns of the universe. These cosmic cities are among the most massive structures ever found. Each one contains trillions of stars, endless rivers of hot gas, and colossal black holes at the centers of galaxies. Imagine standing on the edge of such a city, an ocean of galaxies stretching farther than sight, each glowing faintly in the cosmic night. The scale overwhelms, yet the beauty feels strangely familiar, like lights across a horizon. What makes clusters fascinating is their role as hubs of the cosmic web. The filaments, like highways, all lead here, delivering streams of galaxies into the cities. Over time, clusters grow larger and larger, gathering mass from every direction. It is as though the universe itself funnels creation into these centers, building monuments of gravity that will last for billions of years. But clusters are not quiet. They are full of energy. Galaxies collide, stars are torn apart, and hot plasma glows at temperatures of millions of degrees. They are alive with motion, a ceaseless churn of creation and destruction. These are not static museums of galaxies, but dynamic, ever-changing places where the future of the universe is forged. And as incredible as they are, clusters are still only part of something larger. Step back farther, and you'll see that even these colossal cities belong to walls and filaments. Neighborhoods inside a web so immense that even the greatest clusters are only pieces of its structure. The great walls that span billions of light years. Among the grandest discoveries of the last century were the Great Walls, structures of galaxies stretching billions of light years across. These are not walls in the sense of barriers, but sheets of galaxies arranged side by side, forming boundaries in the cosmic web. Imagine standing before a cliff face that never ends, rising and stretching beyond sight. Only this cliff is made of galaxies themselves. The Sloan Great Wall, one of the most famous, stunned astronomers when first mapped. It spanned a distance so vast that light would take over 1 billion years to cross it. Think about that. 1 billion years of light just to move from one side to the other. It is almost impossible to grasp, yet it exists, quietly holding galaxies like bricks in an infinite wall. These walls reveal the architecture of the cosmic web in breathtaking clarity. They are the ridges of the universe where filaments meet, where clusters align, where matter collects into colossal sheets. Between them lie enormous voids, hollow bubbles where very little exists. The walls and voids together give the web its honeycomb-like pattern, a balance of fullness and emptiness. What strikes us most is how orderly this arrangement is. Instead of chaos, we find rhythm, galaxies repeating across unimaginable distances, creating structures that defy the idea of randomness. It almost feels like the universe prefers patterns, echoing designs we find in crystals, rivers, and even in the living body. The same geometry appears again and again. And so, the Great Walls remind us, even at its largest scales, the universe chooses order. What looks like emptiness from Earth is, in truth, one side of a structure that spans beyond imagination, linking us into a cosmic architecture older than time itself. Filaments, stretching farther than imagination. If the Great Walls are the ridges of the universe, then the filaments are its threads. These are the highways of galaxies, stretching farther than any other structure known. Each filament is a bridge of dark matter and galaxies, extending for hundreds of millions of light years. They are the strings upon which the jewels of the universe are strung. To picture a filament, imagine a string of pearls, each pearl a galaxy cluster, connected by invisible threads. These strings span the dark voids, linking distant corners of the cosmos together. Through them, galaxies flow like cars on an endless highway. The filaments are not straight lines, but winding paths, weaving in and out, creating the texture of the cosmic web. What makes them extraordinary is their scale. We humans measure distance in steps, in miles, in light years at most. A single filament can stretch across 1 billion light years, longer than any human concept of distance can hold. They are so vast that our own galaxy is only a tiny fleck lost along one of these threads, barely noticeable in the grand design. Filaments are also where galaxies are born. Gas flows along them, feeding the clusters at their intersections. Without these threads, galaxies would starve, left adrift without fuel for new stars. They are the veins of the cosmos, carrying life-giving material across the dark. In every sense, they are the supply lines of the universe. And yet, as immense as they are, filaments are fragile. Thin compared to the voids they surround, delicate compared to the clusters they connect. They are both the most powerful and the most subtle features of the cosmos, shaping everything we see while hiding in silence from the human eye. Vast voids, dark bubbles between threads. For every wall, every filament, there is its opposite, the voids. These are regions where galaxies are scarce, where matter is stretched so thin it seems almost absent. Imagine standing in a desert so wide that the horizon disappears, with nothing but silence stretching in every direction. That is what the voids are in the cosmic web. Immense bubbles of near-nothingness, sometimes hundreds of millions of light-years wide. But emptiness is not meaningless. These voids shape the web just as much as the filaments. By expanding, they push matter into walls and threads, creating contrast between fullness and absence. The voids are the negative space of the cosmos, carving out the pattern that makes the web visible at all. Without them, the universe would not have form. What's most haunting about voids is their silence. While clusters roar with collisions and filaments hum with the flow of galaxies, the voids are quiet. They are the loneliest places known, where entire galaxies drift without neighbors for millions of light years. If clusters are cities and filaments highways, then voids are deserts, vast and desolate, yet essential to the landscape. And still, even the voids hold mystery. Recent studies suggest they are not completely empty. Dark matter may flow faintly through them, and subtle patterns of gas may still linger. Perhaps they are not barren, but simply quieter, less crowded. Like the pauses between notes in music, they are the spaces that give the song of the cosmos its rhythm. To look upon the voids is to confront both fear and wonder. They remind us how small we are, yet also how much beauty can exist in emptiness. The cosmos breathes through its contrasts. Fullness and absence, light and dark, clusters and voids. The dance between matter and emptiness. When you step back and look at the web as a whole, what you see is a dance. Matter and emptiness weaving together into one great design. Clusters, walls, and filaments play the role of fullness. Voids play the role of absence. Together they form the pattern of creation. Without one, the other could not exist. It is a cosmic yin and yang, balanced across eternity. This dance is not static. It evolves. Matter flows into clusters. Voids expand. Filaments stretch. Over billions of years, the pattern shifts, yet the balance remains. It is as if the universe knows how to keep itself in harmony, allowing both fullness and emptiness to have their place. Neither dominates completely. Both are essential to the story. The beauty of this dance is its universality. You see it everywhere. In the spaces between leaves, in the gaps of a woven cloth, in the silences that make music possible. The universe repeats its truth across all scales. That emptiness is not nothing, but part of the rhythm that makes something possible. For us, it offers a lesson. We often fear emptiness in our lives. Silence, loneliness, absence. Yet the cosmos itself shows that emptiness is necessary. Without the voids, the galaxies would have no walls. Without silence, the music would have no song. Even in the vastness of space, balance is born from both presence and absence. And so the cosmic web is not just a structure, it is a dance, a graceful, eternal balance between matter and emptiness, fullness and void. As we open more of its story, we step into the harmony of creation itself, written across the stars. The quiet harmony of push and pull. When you look at the web closely, you realize it is not only shaped by gravity's pull, there is also a push, dark energy, an unseen force stretching the universe wider and wider. Together, pull and push create the balance of the cosmos. Galaxies gather in filaments because gravity tugs them inward, while dark energy stretches the fabric of space outward, keeping the dance alive. It is this harmony that prevents the universe from collapsing into itself or flying apart into nothing. Like a pendulum swinging endlessly, the cosmos balances these forces, and though we cannot see them directly, their effects are written into the map of galaxies. Every cluster, every filament, every void is the result of this quiet partnership of opposites. Imagine inhaling and exhaling, the chest rising and falling in perfect rhythm. That is how the universe breathes, only its breaths are measured in billions of years. Expansion and contraction, pull and stretch, all woven together into the same eternal motion. Without it, the web would not exist, and galaxies would have no home. The mystery, of course, is why. Why does the universe contain both pull and push? Why does it prefer balance over chaos? These are questions science has not yet answered, but the pattern itself is undeniable. The universe is not random in its growth. It chooses a harmony deeper than we can fully understand. And perhaps that is why gazing at the night sky feels so calming. Somewhere deep within, we recognize the rhythm, a cosmic balance reflected in our own breath, in our own heartbeat, in the way life itself finds balance between tension and release. Galaxies as beads on invisible strings. If you trace the filaments closely, you'll notice galaxies often line up like beads on a string. These alignments are not coincidence. They are the direct result of the web's invisible structure. Gravity guides them into rows, and dark matter holds them in place. Seen from afar, it looks as though the universe has threaded galaxies together, one after another, across the dark. This image is powerful because beads on a string suggest design. A necklace is made to be worn. A rosary is made for prayer. But here the beads are galaxies, and the string is a filament, billions of light years long. To us it is almost unfathomable, and yet that is what the maps of the universe reveal. These strings are not fragile, they are dynamic highways of matter, channeling gas and galaxies toward clusters. Along them, galaxies grow, collide, and evolve, each one influenced by its neighbors. Like beads sliding down a thread, they cannot escape their path. They are bound by the hidden string that carries them. Sometimes astronomers wonder if these alignments hold secrets. Could the direction of the beads tell us about the early universe? Could their spacing reveal deeper laws of nature? We don't yet know, but the patterns are too clear to dismiss. The beads are there, waiting for us to read them. And maybe that's the most haunting thought of all, that the universe has left clues in plain sight, arranging galaxies in ways that feel almost intentional, as if it wants us to notice the thread, to see that everything, even at the largest scales, is connected by invisible ties. Superclusters, binding into hidden maps. Beyond clusters, beyond even filaments, lie superclusters, the largest gatherings of galaxies known. These are vast territories where countless clusters and filaments interlock, forming maps of unimaginable size. Our own Milky Way belongs to one. The Laniakea supercluster, a sprawling region that includes over 100,000 galaxies, all bound together in the same cosmic flow. To understand a supercluster, imagine a continent. Cities are clusters, highways are filaments, and the land itself is the supercluster, the whole interconnected region. Within it, galaxies drift toward common centers, pulled by immense gravitational currents. It is like watching entire nations of galaxies slowly migrate across the landscape of space. What's astonishing is how superclusters fit into the larger web. They are the brightest knots, the most crowded crossroads where filaments converge. When mapped, they form a hidden atlas of the universe, vast regions drawn not by borders or rivers, but by gravity itself. We live inside one of these maps, though most of us never think about it. And what do these maps tell us? That the universe is not random. It has geography, terrain, landmarks. The cosmic web is not chaos but order, a cartography that binds galaxies into meaningful patterns. It is, in a sense, the architecture of existence itself. When you think of it this way, you realize we are not just citizens of Earth or the Milky Way. We are citizens of Laniakea, one supercluster among many, stitched into the larger fabric of the cosmos. Our true home is far bigger than we imagine, a cosmic web that mimics neural pathways. Here is where the story takes an eerie turn. When scientists compared maps of the cosmic web to maps of the human brain, they found striking similarities. The filaments of galaxies look like neurons. The clusters resemble nodes where signals converge. Even the ratio of connections follows a similar pattern. It is as if the universe and the mind are mirrors of one another. This resemblance is more than poetic. Both systems are networks built to carry information or matter across vast spaces. In the brain, neurons pass signals. In the cosmos, filaments pass galaxies, gas and light. Both thrive on balance. Too much connection, and chaos erupts. Too little, and the system collapses. The parallels are uncanny. Of course, we do not mean the universe is literally a brain, but the similarity whispers something profound, that nature repeats itself, from the tiniest cells to the largest structures in existence. Patterns echo across scales, reminding us that we are not separate from the cosmos, but built in its image. This is why staring into the night sky can feel so personal. When you see the threads of the web, you are also seeing the echoes of your own mind. The same geometry that holds galaxies in place is present inside your thoughts. You carry the universe within you not as metaphor, but as pattern. And so the cosmic web becomes more than astronomy. It becomes a reflection, a reminder that perhaps the universe is not out there, separate and cold, but within us as well, alive in the very wiring of consciousness itself. The strange familiarity between brain and cosmos. The more we study the resemblance, the stranger it feels. The brain contains billions of neurons connected in a network that generates thought. The universe contains billions of galaxies connected in a web that generates structure, different in scale, yet hauntingly familiar. It's as if we are looking at two versions of the same design, one small, one vast. Even the proportions align. In both brain and cosmos, only a fraction of matter or neurons carry most of the activity, while the rest serve as silent background. Both rely on sparse, efficient connections, ensuring energy flows where it's most needed. Efficiency, balance, and rhythm. The same laws apply at every scale. For some, this resemblance feels like coincidence. For others, it feels like a clue, a hint that the universe has deeper principles, patterns that repeat because they are fundamental to existence itself. If neurons and galaxies both weave webs, maybe connection is the law of creation, whether for thought or for stars. Think about what that means. Every time you form a memory, every time a thought sparks across your brain, you are echoing the same patterns that sculpted galaxies. The same mathematics guiding the cosmos is alive in your own mind. The web outside mirrors the web within. And that is why the cosmic web feels strangely familiar. It is not foreign, not alien. It is a pattern we already know because it is part of us. To look into the universe is to look into a reflection of the mind itself, stretched across the silence of space. How light bends along invisible highways. Light may seem like the fastest, freest traveler in the universe, yet even it cannot escape the web. As it journeys across billions of years, the filaments and clusters bend it, twisting its path like water flowing around stones in a river. This bending is not visible to the naked eye, but telescopes catch it. Warped arcs of distant galaxies stretched into strange shapes. The universe itself becomes a lens, revealing the threads of its own hidden structure. Gravitational lensing is one of the few ways we know the cosmic web is real. When light curves where it shouldn't, we infer the presence of dark matter, the scaffolding pulling it off its path. Imagine walking in fog only to see beams of a lighthouse bend and stretch mysteriously. You would know something was there in the mist, even if you couldn't see it directly. That's how light whispers to us about the web. What's haunting is that the light we see tonight has traveled for billions of years, weaving through invisible highways, leaving behind a record of the journey. Each bend, each curve is a breadcrumb trail, showing us the skeleton of the cosmos. Light is not only a messenger from distant stars, it is also the map maker of the hidden web. To think that photons, the tiniest packets of light, can trace the largest structures in the universe is humbling. A single particle, born in the furnace of a star, carries within it the story of the web that shaped its path. Every time we look at the night sky, we are not only seeing light, but reading the signature of invisible highways carved into the cosmos. And perhaps that is why starlight feels so magical. It doesn't just shine, it remembers, it carries secrets of the cosmic web, offering us glimpses of the architecture that holds existence together. Gravitational lensing, revealing what's hidden. One of the most remarkable gifts of the web is its ability to act as a natural telescope. When light from a distant galaxy passes near a massive cluster, it bends, magnifying the galaxy far beyond what our instruments could see alone. This phenomenon, called gravitational lensing, allows us to peer deeper into space than ever before. It is as if the universe itself helps us look at its secrets. Sometimes lensing reveals galaxies so faint and far away they would otherwise remain invisible. These ancient galaxies carry clues about the early universe, when the first stars ignited, when the first threads of the web began to form. Without lensing, we might never know they exist. The cosmic web, in bending light, also unveils its own history. The images from these lenses are mesmerizing. Galaxies stretched into arcs, rings of light encircling invisible clusters, like halos drawn by gravity itself. They look almost artistic, as if the universe is sketching patterns across its own canvas, and each curve, each distortion, tells us something about the mass hidden there, how much dark matter lies within, how strong the filament is, how the web shapes its surroundings. What's profound is that this bending doesn't just reveal the distant, it reveals the unseen. It allows us to map dark matter, to measure the invisible. Without lensing, the cosmic web would remain a theory. With it, we can trace the unseen highways, painting pictures of a structure that refuses to reveal itself directly. And so every warped arc of light becomes more than a curiosity. It becomes evidence, proof that we live inside a universe far richer than the eye perceives, a place where even the bending of light is a reminder that we are surrounded by an architecture too vast to ignore. Cosmic microwave echoes on the threads. If light tells us about the present web, echoes of ancient light tell us about its birth. This is the cosmic microwave background, the afterglow of the Big Bang. It is the oldest light we can see, spread faintly across the entire sky. But it is not uniform. It carries ripples, tiny variations that became the seeds of the web itself. These ripples are like fingerprints showing where matter was denser, where gravity would later pull galaxies together. Over billions of years, those faint differences grew into filaments, clusters, and voids. The microwave background is not just ancient light, it is the blueprint of the cosmic web, frozen in time for us to read. When scientists map this background, they see patterns that align eerily with the structure of today's universe. The web we observe now was written into existence almost from the beginning, long before stars or galaxies were born. It is like finding a baby picture of the universe, only to realize the features you see are still present today. What makes this remarkable is its accuracy. Computers simulate the universe from those early ripples, and the patterns they produce match the web we see now. It confirms that the invisible structure is not imagination, but reality. The echoes of the Big Bang still resonate in the filaments above our heads. And so when you listen to the faint hum of the cosmos, that microwave background that surrounds us everywhere, you are hearing the memory of creation itself, the first whispers of the threads that now hold the galaxies in place. Ancient patterns frozen in the afterglow. The microwave background is more than just noise, it is a fossil, a frozen record of how the universe looked when it was only 380,000 years old, a blink of an eye in cosmic time. Imagine a photograph of an infant, kept perfectly preserved, showing the features that will one day shape the adult. That is what the cosmic afterglow offers us. From this frozen light, we see that the universe was not smooth, but dappled with tiny spots of heat and cold. These spots were the seeds of galaxies. The slightly hotter regions pulled in more matter, while cooler spots thinned into the voids. It is extraordinary to think that the entire cosmic web we see today, billions of galaxies spread across billions of light years, began from such tiny differences in temperature. It shows us that complexity can arise from the smallest beginnings. A fraction of a degree here or there determined where stars would form, where clusters would grow, and even where life might one day emerge. The grandest architecture of the universe was hidden in these subtle, almost invisible variations. What's haunting is that this pattern has remained unchanged in memory. Those ripples are still visible to us, faint but clear, as if the universe left behind a note reminding us of its origins. Every map of the cosmic web today traces back to those ancient fingerprints frozen in the afterglow. And perhaps that is why studying the background feels almost spiritual. It is like looking at the face of creation itself, preserved in light older than every star, every planet, every breath we take. Traces of a web born from the Big Bang. From the moment the universe began, the web was written into its destiny. The Big Bang did not create chaos, it created a pattern, tiny fluctuations that over billions of years stretched and grew into the cosmic filaments we now see. The web is not an accident. It is the natural outcome of those first conditions, the script written at the dawn of time. Every filament today can trace its ancestry back to a ripple in that first fireball. Every cluster is the child of a slightly denser region of matter. Even the vast voids are the offspring of cooler, emptier patches. The entire architecture of the cosmos was born in that single, explosive moment. We are, quite literally, living inside the unfolding of the Big Bang's original design, This realization is humbling. It means the night sky is not random, but ordered from its very birth. The stars we see, the galaxies we map, the filaments we trace, all follow a pattern written before the first atoms even cooled. The web is the memory of creation, still visible billions of years later, and yet it is still alive. The web continues to grow, expand, and evolve. The Big Bang gave it its beginning, but gravity, dark matter, and dark energy continue to sculpt it. The story is not finished. We live in the middle chapters of a tale that began long before us and will continue long after. To gaze into the web, then, is to gaze into time itself. We see not only what is, but what was, and perhaps even hints of what will be. The cosmic web is not only the structure of the universe, it is its history, its present, and its future woven together in one endless thread. How small ripples became vast structures. The web began humbly. At the dawn of time, the universe was almost perfectly smooth, a glowing sea of particles and light. But not entirely. There were tiny ripples, fluctuations in density so faint they were nearly invisible. These ripples, over billions of years, grew into the filaments, clusters, and voids we see today. It's astonishing to think that the grand architecture of the cosmos was born from differences smaller than a grain of sand on a beach. Gravity turned these ripples into scaffolding. Denser regions pulled more matter, becoming seeds of galaxies. The emptier spots stretched wider, forming voids. Slowly the contrast sharpened. Like frost forming patterns on glass, the universe carved itself into intricate designs from the tiniest imperfections. The beauty of the cosmic web lies in this truth. Complexity blooms from the smallest beginnings. This mirrors life itself. Great forests grow from tiny seeds, rivers carve valleys from drops of rain, galaxies form from ripples in ancient light. The web reminds us that even the faintest difference, given time, can shape the destiny of an entire universe. Nothing is too small to matter. When scientists simulate the universe's birth, they begin with these ripples, run the clock forward, and the same filaments emerge, the same walls, the same voids. It is confirmation that the cosmic web is no illusion. It is the natural consequence of a universe that began with tiny, uneven whispers of matter and light. And perhaps that is why gazing at the web feels so moving. It tells us that perfection is not required for greatness. Even tiny flaws, even subtle ripples, can birth galaxies that span eternity. Seeds of galaxies sprouting along filaments. As the filaments grew, they became nurseries. Gas and dark matter flowed along their veins, collecting at crossroads where the first galaxies were born. Think of water running through channels in the earth, pooling into lakes and rivers. In the same way, filaments carried the material for stars, pooling into clusters that lit up the cosmos. These seeds of galaxies were fragile at first. Clouds of gas collapsing into stars, bound together by gravity, forming the earliest spirals and ellipticals. Along the filaments they grew like blossoms on a vine, each one connected to the thread that nourished it. Without the filaments, galaxies would have been scattered dust. With them, they became the glowing islands of light we see in the night sky. What's extraordinary is how orderly this process is. Galaxies did not form everywhere. They sprouted along invisible lines like flowers guided by hidden roots. Even now, billions of years later, galaxies still grow and cluster along filaments. The web continues to feed them, carrying gas and matter across distances too vast for imagination. The seeds also carried memory. The earliest galaxies grew in the densest parts of the filaments, and their descendants still sit in those same regions today. Our Milky Way itself was born along one such thread, shaped by currents of matter older than the stars inside it. We are, in a very real sense, children of the cosmic web. And when you trace the stars in our sky back to their origin, you find the same truth. Every light you see began as a seed sprouting along an invisible filament, nurtured by a thread you cannot see, but that has always been there. Expansion. Stretching the web ever wider. Even as galaxies formed, the universe itself was expanding. Space was stretching like an inflating balloon, carrying galaxies farther and farther apart. At first, this might seem like it would tear the web apart, but instead, the expansion worked with gravity, pulling the filaments taut, stretching them wider while still allowing matter to flow along their veins. The result was a balance between growth and separation. Filaments became longer and thinner, spanning ever greater distances. Clusters grew at their intersections, swelling as matter flowed inward. The web expanded, but it did not dissolve. It became grander, more intricate, its threads reaching across the widening universe. This expansion continues today. Galaxies still drift away from one another, carried by the stretching fabric of space. Yet the web persists, holding them together in larger structures. It is like a fishing net being pulled wide. The knots grow farther apart, but the net itself remains intact. The cosmic web is resilient, its pattern enduring even as the universe swells around it. What's humbling is how relentless this expansion is. There is no edge, no stopping point. The web grows endlessly, and with it, the canvas of creation itself. Every night sky we see is only a snapshot, a frozen moment in a universe that is stretching without pause. And still, the filaments whisper their presence, holding galaxies in place, proving that even in a universe always expanding, connection endures, silent tensions between gravity and dark energy. At the heart of the web lies a cosmic struggle, gravity pulling matter inward, dark energy pushing space outward. These two forces shape everything. Gravity builds the filaments, clustering galaxies together. Dark energy drives them apart, stretching the web wider. The universe is a quiet battlefield between pull and push, neither side winning completely. This tension is delicate. If gravity were stronger, the universe would collapse back into itself, tearing the web apart. If dark energy dominated fully, galaxies would fly apart too quickly to form structures at all, but instead they balance, creating a universe that is expanding, yet still structured. It is a razor's edge, and somehow the cosmos walks it perfectly. Imagine holding a rope, pulling one way while a friend pulls the other. The rope grows taut, stretching but never breaking. That is what the cosmic web is. A rope stretched across infinity, pulled by opposing hands, neither side letting go. It is this tension that allows the filaments to exist, that allows galaxies to form, that allows stars to shine. The mystery, of course, is why. Why do these two forces balance so precisely? Why did the universe choose this path instead of collapse or chaos? Science has no final answer. For now, we marvel at the fact that the balance exists at all, that the universe holds its shape across billions of years. And perhaps in that mystery there is a lesson, that balance is not weakness. It is the strength that holds everything together, from the smallest life to the largest web of galaxies. A universe balanced on unseen forces. When you step back, what you see is astonishing. The entire cosmic web exists because of forces we cannot see. Gravity, invisible yet undeniable. Dark matter, unseen but essential. Dark energy, mysterious yet overwhelming. The visible stars and galaxies are only the surface. Beneath them lies an ocean of unseen power, balancing everything in silence. This balance is fragile. Change the strength of gravity, and galaxies would never form. Change the power of dark energy, and the web would unravel. Yet somehow the universe has chosen just the right mix, just the right balance, to allow the cosmic web to emerge. It is as though existence itself depends on this invisible harmony. We often think of the universe as chaotic, random. But the deeper we look, the more we see precision. Forces calibrated so finely that life itself can emerge. Patterns repeating across scales from neurons to galaxies, invisible scaffolding holding everything in place. It feels less like chaos and more like design, a design we may never fully understand, but that we are lucky enough to glimpse. This realization changes the way we see the night sky. Every star, every galaxy is a symbol of that balance. They shine not because of themselves alone, but because of the harmony of forces that allow them to exist. The cosmic web is not just structure, it is proof that the universe has chosen balance over chaos. And so when you gaze upward, remember this: the stars are not solitary. They are woven into a net of unseen forces, balanced so perfectly that it allows both galaxies and life to exist. We live not in emptiness, but in the embrace of a cosmic balance older than time itself. The largest structures ever found by humans. When astronomers first began to map the universe in 3 dimensions, they expected randomness like stars scattered across a child's drawing. Instead, they uncovered something that staggered the imagination. Structures so large, so vast, that they redefined what big could mean. These were not clusters or single filaments, but walls and networks spanning billions of light years. They became known as the largest structures in the universe, monuments of gravity carved from dark matter itself. Imagine standing before a canyon so wide you cannot see its end, and then multiplying that scale by billions. These structures are so enormous that even light, the fastest traveler we know, would take hundreds of millions of years to cross them. When scientists announced their discoveries, it was like revealing continents hidden in the darkness of space. Continents made not of rock and water, but of galaxies and voids. The shock was not just their size, it was their organization. Instead of chaos, the universe presented order: walls, rivers, clusters arranged like patterns in lace. Humanity realized it was living inside something far more structured than we ever dreamed, a cosmic geography vast beyond words. What makes this remarkable is how these structures stretch our ability to comprehend. Numbers lose meaning at this scale. Words fail. All we can do is compare them to familiar patterns: webs, walls, rivers, continents, and know that these metaphors barely scratch the truth. The scale overwhelms, but the pattern feels strangely comforting. And so the discovery of these larger structures changed not only astronomy but also philosophy. It reminded us that the universe is not endless chaos, but a cathedral of patterns, patiently revealed through light, maps, and time. The Sloan Great Wall and its silent reach. Among these giants, the Sloan Great Wall stands out. Discovered in 2003, it is one of the largest known structures in the universe, stretching over 1 billion light-years across. Imagine trying to walk across it. Even at the speed of light, your journey would outlast human history, civilizations, even planets themselves. It is not a single wall, but a dense arrangement of clusters and filaments forming a cosmic ridge that dwarfs everything near it. The Sloan Great Wall was found during the Sloan Digital Sky Survey, one of the most ambitious attempts to chart the heavens. What astronomers saw stunned them: galaxies arranged in a colossal sheet, like bricks aligned in an infinite wall. The name wall is poetic, but fitting, for this structure divides voids like a boundary, shaping the flow of galaxies across billions of years. What makes the Sloan Great Wall fascinating is its role in the larger web. It is not isolated. It is one ridge among many, a piece of the cosmic honeycomb, but its sheer size forces us to rethink our place. If such structures exist, how many more lie beyond what we can see? How much larger is the web than our current maps allow? The discovery also raised questions about limits. Could structures this large exist within the rules of physics? Some wondered if they challenged cosmological principles, if the web itself was more irregular than we believed. Yet, with more surveys, the patterns held, walls and filaments repeated across the cosmos, each one an echo of the same ancient design. And so, the Sloan Great Wall is not just a discovery. It is a symbol of human curiosity, of cosmic order, and of the vastness that lies just beyond our sight, patiently waiting to be mapped. Patterns that stretch beyond human maps. The Sloan Great Wall is just one piece. With every survey, with every deeper map, new patterns emerge, larger, stranger, more interconnected. Some structures are so big they extend beyond the borders of our current maps, like paintings too wide for the frame. We glimpse part of them, but their true scale is hidden, waiting for us to see more. This reminds us of explorers in the past, mapping coastlines they thought were complete, only to discover continents beyond. Our maps of the cosmos are like that, incomplete sketches of an infinite landscape. Each new discovery expands the horizon, revealing that the universe is more intricate than we imagined. The patterns are not random, but repeating. Filaments connect to walls, walls surround voids, clusters gather at crossroads. It is a geometry that feels intentional, as if the universe has chosen to repeat its design at every scale. And because our maps are still small compared to the whole, we know there are structures larger than anything we've yet named, waiting beyond our current reach. What humbles us most is that we may never see it all. The speed of light sets a boundary, a horizon we cannot cross. Beyond it, the web continues, expanding forever. Our maps will always be incomplete. Yet that incompleteness makes them more beautiful, because every map is an invitation to imagine what lies beyond. And perhaps that is the greatest gift of the web, not only what it reveals, but what it hides, keeping us searching, wondering, dreaming of the patterns still waiting to be found. When observations meet imagination, the cosmic web exists at the edge of what we can observe. We cannot see it directly. We infer it through light, through lensing, through surveys of galaxies. Our instruments provide fragments, like puzzle pieces scattered on a table, and yet with imagination we piece them together into a picture of astonishing beauty. This is where science and imagination blend. Astronomers collect data, redshifts, positions, distortions. But to see the web as a whole, they must imagine its structure, connect the dots, run simulations. It is both mathematics and artistry, observation and vision. Without imagination, the web would remain hidden. Without observation, imagination would drift without anchor. This partnership has defined our understanding. Every great leap in cosmology has required both, the rigor of evidence and the daring of vision. When maps showed clusters, imagination revealed filaments. When data showed filaments, vision suggested walls. And each time, the universe confirmed more than we dreamed, offering back patterns richer than expected. What makes this blend powerful is that it mirrors the web itself. Just as galaxies are connected by invisible threads, so too are science and imagination connected, weaving together a picture larger than either could alone. The cosmic web is not only a structure of matter, it is also a structure of human thought, built from the balance of fact and wonder. And perhaps that is why learning about it feels like storytelling. Each discovery is a chapter, Each observation is a sentence. Each imagination is a whisper, filling the silence between the stars. The universe becomes not just a map, but a story unfolding before our eyes. Simulations, recreating the invisible. Because the web cannot be seen directly, scientists turn to simulations. Digital universes built inside computers, where physics runs forward in time from the Big Bang to now. These simulations are breathtaking. They begin with ripples of ancient light, feed in the laws of gravity and expansion, and watch as threads, filaments, and clusters form naturally. What emerges on the screen looks almost identical to the real maps of the cosmos. One of the most famous, the Millennium Simulation, recreated a patch of the universe with billions of particles, showing how dark matter sculpts the web. Watching it is like watching creation unfold in fast-forward, galaxies blooming along filaments, clusters swelling at intersections, voids hollowing into silence. It confirms what we suspect. The cosmic web is not only theory, it is reality, reproducible under the same laws that govern our own sky. These simulations also let us see farther than telescopes. They predict what lies beyond our horizon, what the web might look like at scales we cannot yet observe. They test scenarios with what happens if dark energy changes, if dark matter is different. Each simulation becomes a window into alternate universes, showing how delicate the balance of forces truly is. What's profound is how human hands, typing code into machines, can recreate the universe itself. It is as if imagination, mathematics, and technology together have become mirrors of the cosmos. And the fact that these digital webs match the real one so closely tells us something humbling. The universe, in all its vastness, obeys laws simple enough for us to glimpse, yet deep enough for us to never fully grasp. And so simulations are not just science, they are art. They allow us to see the invisible, to witness the silent architecture of galaxies, and to understand, however faintly, the grand design that surrounds us all.